Hello guys, welcome to PracBee Education. So today we are going to solve the previous year questions from the topic circle for class 10th CBSE board exams, right? And this is going to be very important. So let's start. So the topic circle, it's an important topic for the board exams. And if we try to know about the weightage of this particular topic, overall you are going to have 7 marks from this particular topic, right? Obviously you will be having the 1 mark questions from this, like objective questions, right? And obviously you can have long questions from this particular topic. So what are the things that we have to cover up in this particular topic? So mostly we are going to deal with the tangents, the common tangents, secants, and then we are having few theorems. So one by one, let us say, first start with the theorems. So the theorems, we are going to have only two important theorems here, and obviously the concepts from the previous classes and the normal concepts like Pythagoras theorem and all those theorems are already there. So the first theorem that we have here is like the tangent at any point of a circle is perpendicular to the radius through the point of contact. It means this OP should be perpendicular to this tangent AB. So look, what is the concept that we are going to use here? Look, whenever we have a point and a line, what do we mean by the distance of this point from this line? So the distance means the perpendicular distance, and you know this perpendicular distance is the shortest distance. Why? Because when you take any other point and you join that, look, this is going to be the hypotenuse in this triangle. Hypotenuse is the longest side. So obviously this distance PA is going to be greater as compared with PB. So therefore we can say that whenever we are talking about the perpendicular distance, that is the shortest distance. So here what you just have to write that, okay, let us consider a point Q on the tangent AB other than the point P. Here P is the point of contact, right? Now, this is the point R where OQ intersects the circle. So what we can write here like OQ equals to OR plus RQ. OQ negative OR is going to be RQ. RQ is the distance. Distance is always positive. So it's going to be some positive number. Now OR and OP both are the radius. So we can write OQ negative OP as some positive number, right? So therefore we can say that OQ negative OP is greater than 0. It means we get OQ is greater than OP. In the same manner, if you take some other point like A or B, there also similarly what we can prove here that similarly we can prove that OA is also greater than OP, OB is also greater than OP. So therefore what we can conclude that OP is the shortest distance. And if it is the shortest distance, then it is going to be the perpendicular distance, because the shortest distance is perpendicular distance always, right? So from here we can conclude that the radius through the point of contact is going to be perpendicular to the tangent, right? Now coming to the second theorem. The second theorem is like, okay, the length of the tangents from an external point, they are going to be equal. It means you have to prove that AP equals to AQ. And for this, you know, it's going to be quite easy. Look, you join O with P, O with Q here with P and Q are going to have 90 degrees. Right now we have proved it, right? So very easy. It's going to be very easy. In triangle OPA and triangle OQA, just prove them congruent. You have angle P equals to angle Q, both 90 degrees. So right angle is there, hypotenuse OA equals to OA, the common side. And then you have OP equals to OQ. This is the radius. So you can use here right angle hypotenuse side congruency, and you can say triangle OPA is congruent to triangle OQA, and therefore by CPCT what we can say AP equals to AQ, right? So therefore the length of tangents from an external point to a circle, they are actually equal, right? So look, these are the important theorems, and we will be using only these two theorems and obviously the concepts from the previous classes and previous topics that we are going to use here to solve the questions. So, okay, coming to the first question, this was being asked in 2024, means the last year, right? So, in this question, AB is the diameter, okay? O is the center, okay? AQ and B, AQ, BP and PQ. AQ, BP and PQ. These are the tangents to the circle, right? Okay. Now prove that POQ. POQ means this angle we have to prove as 90 degree. So look, what we can do here, we can give some name to this angle like this angle. You can give some name and then you do one thing. This point of contact is joined with O. Okay. So look what we can do actually here. This triangle and this point we can give some name like R. So the triangle AOQ, right? And triangle ROQ, we can prove them congruent, right? How we can prove them congruent? It's quite easy, no? At A we have 90 degree, at R we have 90 degree, right? So right angle is there, hypotenuse, OQ is the common, and then OA equals to OR, that is the radius. So if they are congruent, therefore you can say that angle AOQ will be equal to angle ROQ. Both we are giving some name, okay? Like we can say X. And similarly, you will have this triangle ROP congruent to BOP. So you will be having angle ROP equals to angle BOP. We are saying both equals to Y. We are assuming this. It means this is the angle X, this is the angle X, this is the angle Y, this is the angle Y, right? Now see, the sum of all these four angles, X plus X plus Y means X plus X means this angle is your angle AOR plus angle ROB. This gives you the linear pair, so it must be 180 degree, right? So it's going to be 180 degrees. So from here we get 2 times of X plus Y equals to 180 degrees. So X plus Y is your 180 by 2, that is 90 degree. Now X plus Y means this X plus this Y, this is nothing but your angle POQ equals to 90 degree. This is what we have to prove here, right? Okay, let's move to the next question. Like this question, we have a quadrilateral. Inside the quadrilateral, we have a circle inscribed in a quadrilateral. Now, in this quadrilateral, AD is perpendicular to DC. So here we have 90 degrees. So what you can do here, look, it's again a easy question. Just see, just join this center with Q and join this center with P. Now, can you see the point when you join O with P and O with Q? Obviously, you are going to have 90 degree here because this is the tangent. Similarly, AD is the tangent. You will be having 90 degree here. Here again you have 90 degree at D, it's given. So three angles are 90, so fourth angle is also going to be 90. So therefore OPDQ is actually all the angles being 90, it gives you rectangle. But after that, what you can say? Look, OP will be equal to OQ, and obviously DP will be equal to DQ. Why DP DQ? The length of the tangents from an external points. So if the adjacent sides of a rectangle are equal, means it becomes a square. So OPDQ is a square, right? If this is the square, means the length of any side of this square is going to be the radius, right? Now BC length. What is your B to C? This complete B to C length is your given as 30 centimeter, and BS. So BS is given as 24. So BR will also be 24. BR is 24. So CR is going to be 6. 24 plus 6, 30. So QC is again going to be 6. Right? Now the radius is given as 8 centimeter. So OQ is already given as 8 and it is a square. So all the sides are equal. So DQ is again going to be 8. So look, this 8 plus this 6. So 8 plus 6, it's going to be, so DC is your 8 plus 6. That is going to be 14 centimeter. That's it. So look, quite easy. Once you prove that it is a square, the radius OQ, this is equals to DQ. That's it. This question was again asked in 2024 itself, right? Now, getting to the next question. So, assertion and reason. Look, the tangents drawn at the end points of a diameter of a circular parallel. Yes, it's true. You can say this whenever you take the diametric end points. If you draw tangents there, they are going to be parallel. Now, getting to the reason, diameter of the circle is the longest chord. Yes, this is also the true statement. But so what? Is this the correct explanation? Diameter of the circle is the longest chord. That's okay. Look, assertion is true. Reason is also true. But do you think this reason is the explanation for this assertion? No. The diameter being the longest chord means what? Nothing. Why? The tangents are parallel. For that we have a different reason, because the center here we have 90, here we have 90. So these are co-interior angles, right? Or you can think of this as 90, so alternate interior angles equals, that's why they are parallel. So that is going to be the reason, right? So yes, both the statements are true, but reason is not the correct explanation of the assertion, right? Now getting to the next question. So here in this question, PA and PB to the circles, okay, these are the tangents. Center is O from point P. And look, we have 90 degree at P. Now P to A length is your 5 centimeter, P to B is your 5 centimeter. You have to find AB, join A with B. At P we have 90, so just use the Pythagoras theorem. So AB square is going to be equals to PB square, means 5 square plus 5 square, right? So it's 25, 25, 50. So AB is going to be 5 root 2. So B is the correct answer. Quite easy, right? Just use the Pythagoras theorem. And why these two sides are equal, PA, PB? Because the length of the tangents from an external point, they are always equal. Going to the next question. So in this question, so 80 is the tangent, okay, and this angle C80 is given to you as 90 degree. We have to find the angle CBA. CBA means we have to find this angle. So look, this is 40 degree and overall this is going to be 90 degree. It means it's going to be 50 degree. And AB is the diameter. And you know, in class 9th, we had a theorem, the diameter means angles in the semicircle is 90 degree. So here again, you are going to have 90 degree at C. So this is 90. This angle is 50. 90 plus 50, 140. So it's going to be how much? 90 plus 40 is 90 plus 50 is 140. So it's going to be 40. So the correct option is your option D. If you guys have learnt about the alternate segment theorem, then you can use that particular theorem as well. But here it's not required, right? Directly you can find the answer. Okay, here the given figure PQ is tangent to the circle with center O. Okay, so PQ is the tangent, means here you are going to have 90 degree. So x plus y, so it's 90, no? 90, it's a triangle, so x plus y again has to be 90, quite easy. Then only angle sum property of the triangle has to be used, that's it. And then you have to use that, okay, the radius through the point of contact is perpendicular to the tangent. So this question was asked in 2023, right? Look, the questions are quite easy. The only thing is that you need to have enough practice, and obviously the theorems and concepts you must have in the back of your mind. Now coming to this question, in the figure, a triangle ABC, okay, with angle B is 90 degree, we have 90 degree here. Now with AB as the diameter, one circle has been drawn. This circle intersects the hypotenuse at P. Now at P, a tangent has been drawn, and this tangent intersects the BC at Q. So what we have to prove, that Q bisects BC, means BQ equals to QC. So look what we can do here. You join this P with B. Okay. Now see, BQ will be, or QB is going to be equal with QP. Clear? If somehow we can prove that this QP is going to be equal with QC, then this triangle becomes isosceles, means that is not required. If QP becomes equals to QC, so both QC and BQ becomes equals to QP. It means BQ and QC will be equal. So Q will be the midpoint of BC. So see how we can prove this. So for that, we need to prove this triangle to be isosceles. So this is the plan how we have to proceed. So look, actually the thing is that in this particular case, you join P with B. Clear? So here A to B is the diameter. So it's going to be 90 degree here, right? This is 90 degree. Now, if we assume this angle as something like angle X, so in triangle ABC, angle B is 90 degree, A is angle X, so this C is going to be angle 90 minus X, right? Now, see how we can find this angle. Sorry. So see what we can do here. This angle is your X. Okay. So, and this is your 90 degree, right? So what will be the value of this angle? Which angle we are talking about? QPC. If somehow we can find the value of this particular angle, and if the value of this angle is also going to be something like, you can say here, like if the value of this angle is again 90 minus X, okay, then what we can say, that these two angles are equal, means it's going to be an isosceles triangle, right? So see, this is angle X. Now in this triangle, means triangle PBA, the angle A is your X, means PAB is your X. At P we have 90 degrees, so this angle is going to be 90 minus X. So if this is 90 minus X, and this overall is your 90. So this portion of the angle, it's going to be 90 minus 90 minus x, means it's going to be again x, right? Now, if this is the angle x, since q to b and q to p, they are equal, so it's an isosceles triangle. PQB is an isosceles triangle. So this also going to be angle x. If this is the angle x, this is going to be 90 minus x. It means this triangle is your now isosceles triangle. Triangle QPC becomes isosceles. If this is the isosceles triangle, it means you can say QP equals to QC and QP was equal to QB as well. So from these two equations, what you get here, that QB equals to QC, it means Q is, or you can say Q is midpoint of BC, means Q bisects BC, right? So this is exactly what we have to prove. Clear? Now going to the next question. So see this question, in this question, it's quite easy actually. In the given figure, it's a right angle triangle, right angle at B. AB is given to you as 12 centimeter and BC is given to you as 5 centimeter. Use the Pythagoras theorem. AC will be your 13 centimeter, right? Find the radius of the circle. Now look here, what we need to do here, like you can do one thing. We do have a shortcut formula, but we don't need to go with that. So what you just need to do, join the center with C, join the center with B, join the center with OA. Now area of triangle ABC, it's going to be equal to area of, let the center be O, area of triangle AOB plus triangle BOC plus triangle AOC. Now, see, if you draw the perpendiculars like this, so this perpendicular, if you draw the perpendicular, means simply join this center with the point of contact. It's going to be a perpendicular, right? So if you use half into base into height for AOB, so base you will be taking as AB, height as this radius, right? So here it's going to be half into AB is your 12 into radius R plus half into, for BOC again you will take BC means 5 into radius R plus half into 13 into radius R. You can cancel this half from half, and here it's going to be half into 12 into 5, half into base into half. 12 into 5 is 60 and it's going to be 12R plus 5R plus 13R means 30R. So look, the radius is going to be your 60 by 32 centimeter, right? So this question was asked in 2022. Now coming to the next question. So here we are having a circle is inscribed in the triangle, okay, and having BC as 8 centimeter. B to C is 8, A to B is given as 10 and A to C is 12. Okay, find the length of BL. So look what we can do here. BL and BN, the length of the tangents from an external point, they are going to be equal. So you can assume this BL as X. Look, always I will suggest the things which are equal, you give some common name to them. If you do this, writing the equations and cancelling out the things is going to be quite easy. Always try to use this technique. You will feel that the things are going to be quite easy for you. So this is X, this is X. You can take CL as Y and you can take CM as Y. And let us say this is your Z and Z, AN and AM. So what we can say here is X plus Y. means BC is your 8. Y plus Z means AC, it's 12, and then your X plus Z, it's your AB, that is 10, the equation number 1, the equation number 2, the equation number 3. Just subtract from equation 2, you subtract equation 3. So Z got cancelled, Y negative X, you are getting as 12 minus 10. You can subtract any two equations. Now it's quite easy. So y negative x is your 12 minus 10, 2. Now see, this is your fourth and first. Just solve. This is your pair of linear equations, first and fourth. First plus fourth, you simply add, x got eliminated. 2y is your 8 plus 2, 10. Y you get as 5. If your y is 5, y plus z is 12. So z is going to be 7. X plus y is 8. So x is going to be 3, right? So BL is nothing but x. CM is y and AN is your z. That's it. Clear? So this question was asked in 2019. Coming to the next question. So in this question, again, PQ is tangent to the circle. Okay. Center is at O and angle BAQ. That is your 30 degrees. So that BP equals to BQ. BP equals to BQ. That's okay. Look, AB is the diameter here. Means this angle has to be 90 degree. Angle in a semicircle, right? And you can do one thing here. You can join O with Q, right? So, just join this. So if you join O with Q, look, O to Q and O to A, they are equal. So this is an isosceles triangle. So this angle is going to be 30. If this is the 30, total is 60, total is 90. So this angle has to be how much? 60 degree. If this is 60 degree, then obviously, if this is 60 degree, this also has to be 60 degree. Why? OQ and OB are equal, isosceles. If this is the 60, obviously this angle also has to be 60, right? Now see, OQ is radius through the point of contact. So total angle OQP has to be 90 degree, out of which OQB is your 60. So this angle finally is your 30 degree, right? Now see, this is 60 degree using linear pair. This is going to be 120 degree. If this is 120, 120 plus 30, 150. So this is going to be your 30 degree. So look, triangle BQP becomes isosceles with angle BQP equals to BPQ. Therefore, BQ has to be equal with BP. This is exactly what we have to prove, right? That's it. Look, this question was asked in 2024, right? Okay, getting to the next question. In this question, AB, BC, CD, DA are tangents to the circle with center O forming a quadrilateral ABCD. So that angle AOB. Look, again, in this question, what you need to do here, okay, first what you can do means point of contact you can join with the center. Join with the center. Point of contact join with the center. Point of contact join with the center. Point of contact join with the center, right? Now, see how we can solve this. We can give some name like, okay, P, Q, R, S. So what we can do here, just see carefully. This triangle with this triangle means triangle OPB and OQB. We can easily prove them congruent, right? How? Look, OP equals to OQ, radius, right? OB is the common, BP equals to BQ. Why? The length of the tangents from an external point. So easily with SSS congruency, you can prove that triangle OPB is going to be congruent with triangle OQB. It gives you what? This angle and this angle equal. So look, we are naming this angle as angle number 1, angle number 2. Similarly, you will be having this triangle OQC and ORC congruent. So angle 1 equals to 2, angle 3 equals to angle 4. Similarly, you will be having ORD congruent with OSD. So angle number 5 equals to angle number 6, and in the same manner, angle number 7 equals to angle number 8. Now you know angle 1 plus angle 2 plus angle 3 plus angle 4 plus angle 5 plus angle 6 plus angle 7 plus angle 8. This is one complete rotation. It has to be 360 degrees, right? Now see, in AOB, what you need to take here in AOB means 1 plus 8. So look, what you can do, 1 and 2 are equal. So 2 you can replace with A. 2 can be written as angle 1, right? So 2 times of angle 1. Similarly, 3 and 4 they are equal. So 3 can be written as angle 4. So 2 times of angle 4. Right? Similarly, 5 and 6 are equal, so 2 times of angle 5. And similarly, 7 and 8 are equal, so 2 times of angle 8 equals to 360. Now see, angle 1 plus angle 8, this is nothing but your angle AOB. And angle 4 plus 5 is nothing but your angle COD. This 2 will go on the right hand side, 360 by 2, 180 degrees. This is what we have to prove here, right? This question was again asked in 2024. Coming to this question, two tangents TP and TQ are drawn to the circle with center at O from an external point T. Okay, prove that PTQ equals to 2 times. So look, what we can do here. Let us name this angle as X. If this is the angle X, this is again going to be the angle X because this is isosceles triangle OQ equals to OP, right? Now see here, if this is the angle X means what will be the central angle? Angle POQ is going to be angle sum property, so 180 minus 2x, right? Now angle POQ plus angle PTQ, it's going to be 180, no? Because angle at P 90, 90. So if you take the angle sum property of the quadrilateral, these four angles added together equals to 180 out 360, out of which P and Q are 180. Now angle POQ, that is your 180 minus 2x, 180 degree minus 2x plus angle PTQ equals to 180 degrees. 180 got cancelled. So you have angle PTQ equals to 2 times of x, and x is nothing but your angle OPQ, right? This we have given the name x. That's it. So this is exactly what we have to prove in this question. And this question was asked in 2023, correct? Okay, let's go to the next question. Quadrilateral ABCD is drawn to circumscribe a circle. Prove that AB. So again, look again, I'm telling you again and again. Just name like, okay, P, Q, R, S, the point of contacts. Now DP and DS, they are going to be equal. So this we can name as X and X. CP and CQ, Y and Y, Z and Z, and let us say U and U, AR and AS. Now see, the left hand side is your AB plus CD. Look how the things becomes easy here. AB is your U plus Z. CD is your X plus Y. That's it. This is the equation number 1. The right hand side is your BC plus AD. Now BC is your Z plus Y and AD is your X plus U plus X. So you just compare the equation number 1 and 2. We have same things. U here, X here, X here, Z here, Z here, Y here, Y here. So from equation 1 and 2, what we can say? The left hand side is going to be equal with right hand side. Clear? That's it. 2020, in 2020, this question was asked. Look, this is again quite an easy. The perimeter is going to be your AB plus AC plus BC. That is the perimeter, right? Now, AB plus AC, and we can break this BC into BD plus CD. And then BD can be written as AB plus BP and AC plus CD can be written as CQ, AC plus CQ, AB plus BP, that is your AP plus AQ. Both AP and AQ. These are the length of the tangents from an external point. They are going to be equal 12 plus 12, that is your 24 centimeter is the perimeter, right? Again, this question was asked in 2020 and the question is quite easy, right? Look, we have solved this kind of question in this session itself. Look, here angle B is 90 degree. OP is again the radius through the point of contact 90 degree. Here again 90 degrees. So obviously the fourth angle 90 degree. So now it's a rectangle, but BQ equals to BP. Adjacent sides are equals. So this is a square. OQBP, it is a square, right? So, in the given figure, a circle is inscribed in a quadrilateral ABCD in which angle B is 90 degree. Okay, it means because of this angle B only, this is a square. If AD is 16, AD is 17, AB is 20, that's okay. DS is 3. If DS is 3, DS and DR, they are going to be equal, no? Length of tangents from an external point. So, this DR is again 3. If DR is 3, total AD is 17. So, AR is going to be 14. AR 14 means the Q is again 14, right? Now, find the radius of the circle and A to B is given to you as 20, out of which AQ is 14, so QB is going to be 6. Now, this is a square, no? So, this, all the lengths, all the sides will have the same length. So, radius is going to be here 6 centimeter. That's it. Clear? Now coming to this question, in this question, AB is given as 7 meter, BC is given as 15 meter. So first of all, use the Pythagoras theorem. AC square is going to be AB square plus BC square, AB square 7 square 49 plus 15 square 225. So 274. So AC is almost going to be 15.55 meter. Clear? Now, so in this particular case and X, what is your X? A to P length has been given the name as the X. So a backyard is in the shape of a triangle ABC, right angle at B. At B we have 90 degree. That's why we applied the Pythagoras theorem. A circular pit means a hole was dug inside it such that it touches the walls. Okay. ACBC means the tangents. AC, AB and BC are the tangents to the circle and they are touching at PQR. AP is X. Find the length of AR in terms of X. So look, AR and AX means AR and AP, they are going to be equal. So AR equals to X only, right? Write the type of quadrilateral BQOR. BQOR. Look, it's going to be a square. Right now we have proved these things, right? This is 90, here again 90, here again 90. So fourth angle 90 and adjacent sides BR equals to BQ. In a rectangle, if the adjacent sides are equal, it's a square. So it's going to be a square, right? Find the length PC in terms of X and hence find the value of X. PC in terms of x. So look, PC is going to be AC minus AP, that is AC minus x. So AC, we have calculated AC 15.55 meters minus x. So this much of meter is the length of PC in terms of x, right? And then find the value of x. So look, if we have to now solve for x, so see how we can solve for x, because the same you can use here as well, right? Now, if AP is x, AR is again going to be x. Now BQ we assume as y, BR as y, CQ as z, CP as z. So write down the equations. So what will be the equations? You will be having equations x plus y means A to B is going to be 7. Y plus z is your 15 and x plus z is your 15.55. Okay. The equation number 1, 2, 3. Just subtract equation 2 minus equation 1. So if you subtract this, y got cancelled, 2 minus 1. So z minus x equals to 15 minus 7, 8. Now what we can do, we can add, let us say this is your equation number 4. So we can add third equation with fourth equation. So if we add these two equations, x got cancelled, negative x, positive x, 2z equals to 15 plus 8, 23.55. So the value of z we get as, so 23.55. So 11.77, right? 15, 2 into 7, 14, again 15, so like this. So this much of meter. So this is the value of z. So if this is the value of z, therefore the value of x is going to be this minus 8 means 11 minus 8, 3.77. And the value of y, x plus y is 7. So 7 minus 3, 4.77. Right? No, not 4.77. It's just a second. So just subtract 8, 7 minus 3.77. So 3.23, right? Now these are the values of x, y, and z. Now z plus x, z plus x, z plus x, z plus x. Now what we need to find here, find x. Okay, we have the value of x as 3.77, right? Now find the value of radius. So how we can find the radius? Look, radius is equals to y. So the value of y itself is the radius, right? And then, yes, so value of y itself is the radius, and then we have to find x. That's it. Nothing else is required. So everything we have here, right? So this is how we can solve. And look, the questions are not so difficult. Only the basic concepts that we have here we need to apply. And look, if you like the solution, if you like this video, please subscribe the channel and do like this video, right? That's a small request. So again, welcome to PracBee education. And look, we have a regular plan. We will be coming up with regular videos. So please keep visiting the site, keep visiting the channel. You will be getting videos for PYQs for each and every topic, right? So that's all for today. Thank you.